Welcome back. Today we're going to be starting our fourth unit, which is on relations and functions. Now in this unit, you're going to be introduced to a lot of new vocabulary, including what is a relation, what is a function. We're going to talk about domain and range, but also a big part of this unit is building equations. And as part of that, we're going to be solving equations. Now that's going to involve some review of algebra. So before we get into the actual unit, today's lesson is just going to be looking at some review of algebra. So right away, we're going to look at some integer rules. What I'd like you to do is pause the video, try some of these on your own, and then we'll talk about them. And welcome back. So I'd like you to take a quick moment to check your answers, see if you've made any mistakes, and then we're going to talk about them. In our first column here, we have -2 plus -3. So that's like owing $2, and now you owe another $3. -2 plus -3 is -5. If I have -2 plus 1, that would give me 1. -2 minus 3 is the same as saying -2 plus a -3, which is also -5. If I have -2 minus -3, that's like -2 plus 3 would also give me 1. In our second column, 2 minus 3 would be -1. So I have $2, I lose $3, now I have -1. Again, 2 minus -3 would be like 2 plus 3, which would be 5. And then we get into multiplication and division. Remember that when I am multiplying an even number of negatives, my answer will be positive. If I'm multiplying an odd number of negatives, I would have a negative value. So a -4 times a -5, 4 times 5 is 20, but I have two negatives, so it will be a positive 20. Then I have -4 times 5. So again, 4 times 5 is 20, but because it's -4 times 5, I will have an answer of -20. -4 times -5, again, I've got two negatives, so that's going to give me a positive. -10 divided by -2, 10 divided by 2 is 5. The two negatives make it positive. -10 divided by 2 will give me -5. And then 10 divided by -2 is also -5. Now, as we start working with algebra and we're solving equations, we need to be able to verify that our answers are correct. So in this particular question, we were solving x plus 2 equals 7, and we determined that the value of x was 4. We want to be able to go back and check our work. And one way to do that is with a left side, right side chart. So for an LSRS chart, essentially what we're doing is we're just dividing our equation into the left side of the equation and the right side of the equation, with the equal sign being our border. So we put the left side of the equation on the left side of the chart, and we put the right side of the equation on the right side of the chart. Then we substitute in our value. In this case, it's x equals 4. We sub in that x value wherever we see an x, and if our answer is correct, both the left side of the chart and the right side of the chart should be equal. We're setting this up as a left side, right side chart because until we've subbed in and verified that our answers are equivalent, we can't really use that equal sign. So mathematically, we need to show that they're equivalent before we can write that equal sign. So here we're going to put in 4. 4 plus 2, typically when we're subbing in, we'll use brackets. 4 plus 2 is 6. Notice that 6 and 7 are not equivalent, so 4 is not a solution to that equation. So for this question, we would say that LS does not equal RS. Now, as we look off to the side, there's some key vocabulary that I want to emphasize. Often I will hear students use expression and equation interchangeably. It's important that you understand they are different, and the directing words are also related to what it is that we're talking about. When we're looking at an expression has no equal sign. We will simplify an expression so we can put it into lowest terms, but we can't actually solve. So often I will hear students talk about solving when we're looking at an expression. If there's no equal sign, all we're doing is simplifying. Now, if there's an equal sign, we are looking at an equation. And when it comes to equations, we are actually solving for the value of x. So we solve equations, but we just simplify expressions. When there's an equal sign, what we're saying is that both sides of the equation have the same value. So when we're thinking about algebra, we're thinking about a balance scale. We're thinking about keeping the left side balanced with the right side. So as we move into solving some algebraic equations, we're going to talk quite a bit about keeping that equation balanced or keeping that scale balanced. Whatever we do to one side of the equation, we're going to have to do to the other side to keep that scale balanced. So let's get started with some equations. As we're working with algebra, what's important to remember is that we are just reversing the process of order of operations. So if you remember when we're talking about order of operations, we're talking about BEDMAS, brackets, exponents, division, multiplication, adding, and subtracting. Some people like to write it as a hopscotch diagram. So we'd have B, E, D, M, and then AS. What that means is that we would do brackets first, then exponents, then dividing or multiplying depending on which one comes first, going from left to right, and then adding or subtracting depending on what goes from left to right. When we're solving an algebraic expression or when we're solving an equation, we're just reversing that process. So we're doing BEDMAS backwards, or some people like to call it SAMDEB. So a number of years ago, as I was tutoring a student who was struggling with some algebra, I randomly came up with this quote and it is kind of stuck. When I think about algebra, I think about algebra being like an onion. So we've got all of these layers, and as we peel away the layers, we're getting to that treasure inside, or the X inside. So for example, if I have X plus 2 equals 5, I have my X, and my next layer is to add 2, and that gave me my 5. So if I want to get to the X, I have to peel away the positive 2, and I do that by reversing my operation. So if the original operation was plus 2, the opposite is going to be minus 2. And as we get into more complex equations, we just have more layers to deal with. As we're peeling away those layers, we are just reversing the order of operations. So I would start by peeling away my adding and subtracting layers, then my multiplying and dividing, then my exponents, and then my brackets. So let's get started. Again, for this first example, I have x plus 2 equals 5. I want to get rid of the 2 because I want x by itself. The opposite operation of adding 2 is subtracting 2. And remember that we need to do that on both sides of the equation. So we would have x equals 5 minus 2, which is 3. Notice that when I had 2 minus 2, those canceled out. Now, over the years, I have seen a number of students that like to draw a line through their equal sign, kind of creating a border between the left side and the right side. This is really helpful, especially when you're starting with algebra. So if you're someone that has trouble keeping track of that left side and right side, or maybe the way you're writing your numbers is causing you to mix up your sides, then I would encourage you to draw that border. Here I have x minus 4 equals 7. So the opposite operation of subtracting 4 is adding 4. So I would have x minus 4 plus 4 becomes 0. So x equals 7 plus 4 is 11. For C, I have 12 equals x minus negative 3. So it might be helpful to rewrite that as x plus 3. And then I want to reverse my operation. I want x by itself. So I'm going to subtract 3 from both sides. 12 minus 3 is 9, and 9 equals x. If you want to rewrite that with the x on the left-hand side, you could do that. So we have x equals 9, x equals 11, and x equals 3. Moving on, we have 360 equals negative 18 times a. So when you see the negative 18 and the a with no symbol in between, that means multiplication. So the opposite operation would be to divide by negative 18. So 360 divided by negative 18 will be negative 20, and that equals a. And again, you could rewrite it with the a on the left. For E, we have 20 equals negative 5 over 3x. Again, it might be helpful to rewrite this in a different way. First, we'll start off just writing it as is. We've got 20 equals negative 5 thirds x. Well, right now I have x being multiplied by the negative 5 thirds. So to get x by itself, I'm going to have to divide by negative 5 thirds. On my calculator, I would have 20 divided by negative 5 thirds. Now, if you're going to divide in one step, it's really important that you keep that 5 thirds in brackets. So that's going to give me negative 12. So I'm going to have x equals negative 12. And again, we did that by dividing by negative 5 thirds on both sides of the equation. Now, another way to write this equation is 20 equals negative 5x divided by 3. And then this can become a two-step problem. First of all, what I want to do is get rid of the divide by 3. So I have negative 5 being multiplied by x, and then I'm dividing by 3. So to do that, I'm going to multiply by 3 on both sides of the equation. That would give me 20 times 3, which is 60. And that leaves me with negative 5x on the right-hand side. Now to get x by itself, I'm going to divide by negative 5. And that would give me negative 12 equals x, or x equals negative 12. Taking a look at f, we have a similar scenario. I have negative 12 over 7 times y equals negative 36. So one option would be to divide negative 36 by negative 12 over 7. Again, if I'm doing that on my calculator, I need to remember brackets. So I would have negative 36 divided by, in bracket, negative 12 divided by 7. and that would give me 21. The other option is to rewrite this as a two-step problem. So I would have negative 12y all over 7 equals negative 36. So my first step would be to multiply by 7 on both sides. Again, what you do to one side, you have to do to the other. That would give me negative 12y equals negative 252. Then I would divide by negative 12 on both sides, and that would give me y equals 21. So as I mentioned earlier, when we're working with algebra, we are just reversing that process. And I talked about algebra being like an onion. We're just peeling away the layers by using those opposite operations. As we move on to two-step equations, we're just adding more layers. So here we have 3x minus 7 equals 8. Remember, with our order of operations, that means that we're multiplying by the 3 and then we're subtracting the 7. So as we reverse that process, we want to get rid of the 7 and then get rid of the 3. So to get rid of the 7, we're going to have to add 7 to both sides, and that's going to give me 3x equals 15. And then I'm going to divide 3 on both sides. X equals 5. Remember that all of these equations can be verified using our left side, right side method from earlier. For b, we have negative 33 equals negative 9a plus 3. As we think about the layers that we want to peel away, we first want to get rid of the positive 3. So instead of adding 3, we're going to subtract 3 from both sides. Negative 33 minus 3 is negative 36, and that equals negative 9a. Now it's important to note here, this does not mean subtract 9a. This is negative 9 multiplied by a. So the opposite operation is not to add 9, again, because we're not subtracting, we are multiplying. The opposite operation would be to divide both sides by a negative 9. And so negative 36 divided by negative 9 is 4. So we have 4 equals a, or we can rewrite that as a equals 4. For c, we have 8 minus n equals 13. So that's like a positive 8 subtracting n. And in order to get rid of that positive 8, we're going to subtract 8 from both sides. That would leave me with negative n equals 13 minus 8, which is 5. And then we would divide by negative 1 on both sides. And that would give me n equals negative 5. Now, personally for myself, I have always had difficulty with negative variables. So often when I'm doing algebra, I will move my variable to make it positive. So another option for this equation is to add n to both sides, which would then give me 18 equals 13 plus n. And then I want the n by itself, so I would subtract 13 from both sides. 8 minus 13 is negative 5 equals n. Notice that the operations are different, but I'm still getting the same answer because I'm still following the rules of order of operations. Moving on to this next set of equations, these are the ones that I often see students struggling with. When we have a variable on either side of the equation, they can be a little bit tricky. Now, as I mentioned in the previous section, I don't like working with negative variables. Whenever it comes to making a mistake, I will usually do it with negatives. So as I'm working with these equations, you're going to see that I have a tendency to always want to move my variable to keep it positive. Other people like to always move their variable to the left-hand side of the equation. They are both correct. It does not matter which way you approach the equation as long as you are still following the rules of order of operations. Now, if you come across an equation where it can be simplified first, please do so, because that's going to make your job easier in the end. For our first equation, we have 7x minus 3x plus 19 equals negative 1. Notice that 7x minus 3x are like terms, so we can combine those first. 7 minus 3 is 4x. Notice the x stays there. It's like having 7 apples minus 3 apples gives me 4 apples. So 4x plus 19 equals negative 1. So now to get x by itself, I'm going to have to peel away the 19 layer and then peel away the 4 layer. So as you start thinking about that algebra as just a series of layers or algebra like an onion, you might be able to start visualizing what those operations are going to be before you get started. In this case, I'm going to subtract 19 and then divide by 4. And what you do to one side of the equation, you need to do to both sides. So I'm going to have 4x equals negative 1 minus 19, which is negative 20. And then to get rid of the 4, I'm going to divide. So I'm going to have x equals negative 5. Now for part B, you'll notice that I have a variable on each side of the equation. So I want to get all of my variables together. Again, because I don't like working with negatives, I'm going to move the 4x. So I'm going to subtract 4x from both sides. And if you want, you can move your numbers at the same time. Since I'm going to have all of my x's on the right-hand side of the equation, I want to have all of my numbers on the left-hand side of the equation. And so to do that, I'm going to add 12 to both sides of the equation. Now, if doing this all in one step is too much for you, just move the x's first and then move the numbers afterwards, or the constants afterwards. So we're going to have 3 plus 12 is 15. 4x minus 4x cancels out. Then we have 9 minus 4x is a positive 5x, and the negative 12 and the positive 12 canceled out. So now I have 15 equals 5x. We're going to divide by 5 on both sides because the opposite of multiplying is dividing, and that leaves me with 3 equals x. Or again, if you want to write it with the variable on the left, x equals 3. Take a moment, pause the video, try C and D on your own, and then we'll come back and check your work. Taking a look at C, you'll notice that I subtracted 6x from both sides, so that would have left me with a 2x on the right-hand side. And then I subtracted 45 from both sides, leaving me with a negative 30 on the left-hand side. Now I have negative 30 equals 2x. To get rid of the 2, I'm going to divide by 2 on both sides, and that leaves me with negative 15 equals x, or x equals negative 15. And for D, notice that I added 8x to both sides of the equation and 17 to both sides of the equation. That left me with 24 on the left-hand side of the equation and 12x on the right-hand side. And then I divide by 12 on both sides. That leaves me with 2 equals x, or x equals 2. For our next section, we're going to take a look at the distributive property. Now, sometimes we can solve an equation without having to use the distributive property if I can divide out a number evenly on both sides. Other times, like with the B example, I'm going to have to use the distributive property. Let's get started. For our first example, we have 5 times 2x plus 3 equals 10. Since 10 is divisible by 5, I can divide by 5 on both sides, meaning there's no need for the distributive property. So I would have 2x plus 3 equals 2. 10 divided by 5 is 2. And then I need to peel away my layers. So in this case, I'm going to subtract 3 and then divide by 2. So subtracting 3 from both sides gives me 2x equals negative 1. And then dividing by 2 on both sides gives me x equals negative 1/2. Now I can also use the distributive property and I will get the same answer. So instead of dividing by 5, I could have multiplied my 5 through. So that would have given me 10x plus 15 equals 10. Again, I'm going to peel away the layers. I'll subtract 15 and then divide by 10. So subtracting 15 from both sides gives me 10x equals negative 5. And then dividing by 10 on both sides would give me negative 5 over 10 in lowest terms would be negative 1/2. So whether I use the distributive property first or divide out that 5, I will still get the same answer. Usually when I'm deciding which way to go, I start by considering whether or not I can divide out a 5 evenly, or I can divide out a coefficient evenly. For B, I have 7x minus 3 times 4x plus 8 equals 11. Now, using my order of operations, I can absolutely subtract the 7x, but it's not going to get me any further. So I'm going to start by using my distributive property. So I'm multiplying in that negative 3. And remember that negative needs to apply to both the 4x and the 8. So I'm going to have 7x minus 12x minus 24 equals 11. Now I can combine my like terms. 7 minus 12 is negative 5, so I have negative 5x minus 24 equals 11. Now I'm just following order of operations. So to peel away my layers, I'm going to add 24 to both sides and then divide by negative 5. So adding 24 gives me 35 on both sides, so I have negative 5x equals 35. Dividing by negative 5 is going to give me x equals negative 7. Taking a look at our last set of examples, here we're going to be looking at cross-multiplying and rational equations. When we're working with rational equations, that means that we have something in the denominator, whether it's a variable or a number. And the easiest way to solve these equations is to get rid of the denominator. And what we can do is multiply the entire equation by our greatest common denominator. And so if I have x over 3 equals 4 over 6, my GCF for 3 and 6 is 6. And so I can bracket the entire equation and multiply by my GCF, which is 6. And when I'm multiplying by 6, that means I'm multiplying by 6 over 1. And so if I were to multiply x over 3 times 6 over 1, that would give me 6x divided by 3, which is 2x. So I would be left with 2x on this side of the equation. And if I multiply 4 over 6 times 6 over 1, that would give me 4 times 6, which is 24, divided by 6 equals 4. Notice that essentially my 6 is canceling out the 6 in the denominator. So I would be left with 2x equals 4, and then I can divide by 2 on both sides of the equation, and I'm left with x equals 2. That method will work for all of these. So for x over 5 equals 10, I can multiply the entire equation by 5, which is multiplying by 5 over 1. The 5's will cancel, I'll be left with x, and then 10 times 5 is 50. For c, I can multiply the entire equation by 2, which is like multiplying by 2 over 1. So as I multiply through, x over 2 times 2 just becomes x. 5 times 2 is positive 10. And 7 times 2 is 14. Make sure that you're multiplying through to the entire equation. As I peel away that 10 layer, I'm just subtracting 10 from both sides. So that's going to give me x equals 4. For d, I have x over 4 plus 5 over 2 equals 7. The GCF for 4 and 2 is 4. So I'm going to bracket my entire equation and multiply by 4, or 4 over 1. 4 times x over 4 just becomes x. 4 times 5 over 2. So 4 times 5 is 20. 20 divided by 2 is 10. And then 7 times 4 is 28. Subtracting 10 from both sides, I have x equals 18. Now, multiplying by the greatest common denominator will work for all of these equations, but there are some special cases where we can also use cross multiplying. If I have, like in example a fraction equal to a fraction and no other adding or subtracting of terms, I can use cross multiplication. And so for these, I like to use a little bunny analogy. When we're doing cross multiplying, we're just multiplying the terms across from each other and putting them on opposite sides of the equal sign. So think about cute bunny, sees cute bunny. They like to have their privacy, so they're going to multiply on this side of the equation or this side of the fence. And then I'm going to have cute bunny sees cute bunny, he crosses over, and they are on their side of the fence. Now again, I'm just solving a one-step problem. I have 6x equals 12, divide by 6 on both sides, and I have x equals 2. Now, if you wanted to do this in one step, you can do that. You're going to multiply the two numbers that are across from each other and then divide by what I call the leftovers. So multiply 3 times 4, divide by the leftovers of 6. Or if we think about our bunnies, cute bunny sees cute bunny, he crosses the fence, they multiply, and then ultimately, as bunnies do, they divide. So 3 times 4 divided by 6. So we're going to have x equals 3 times 4, which is 12, divided by 6 is 2. Taking a look at part B, we can follow that same method. Again, it's just a special case. It only works with certain circumstances, but I have x over 5 equals 10 or x over 5 equals 10 over 1. We can cross multiply, so 1 times x is 1x, and 5 times 10 is 50, and so that means x equals 50. If we wanted to do this in one step, we would have 5 times 10 divided by my leftovers, so 5 times 10 divided by 1. 5 times 10 is 50, divided by 1 is 50. So hopefully this gives you a good refresher of some of the algebra that you've done prior to 10C. We're going to be using these skills throughout the unit, so it's probably a good idea to take some time to just do some practice. There's lots of games online. If you look up basketball algebra or some other algebra games, that would be a good way to refresh your skills. You can also use some of the practice questions in the practice booklet. So that's all I have for you today. Have a great day, and we'll see you next time.